Hey everybody, these are your prime factorization notes. Make sure that your paper is in front of you. Let's do a quick review of the word prime. A prime number has only two factors. 7, for example, the only thing that goes into 7 is 1 times 7. And then factors are numbers that we multiply to get another one. You see that built right in there. So prime factorization, we're going to be dealing with prime numbers. The definition says breaking down composite numbers into a product of primes. So composite numbers have more than two factors. These are just reminders here. So 12, for example, has a whole bunch. It has 4 times 3, 6 times 2, 12 times 1. And the word product, just a reminder here, means to multiply. So those are all things to refresh your memory. So prime factorization is breaking down composite numbers into a product of primes. And you see over here that I've got the words factor tree in parentheses. Factor tree is kind of a way we describe showing how to do this. So you're going to see right now. So on the bottom of your paper you have a 48. 48 is composite. That means there's many numbers that go into 48. So what I'm going to do is I want to try to turn 48 into prime numbers only. So we'll see how to do that here in a second. 48. I need factors of 48. So I'm going to tell you that I'm going to use 6 times 8. Those two numbers will get me 48. So if I look at the 6 and the 8, the 6 is composite and the 8 is composite. So we said we wanted this to be a product of primes. Well, these aren't primes yet. So I'm going to take the 6 and I'm going to find factors of 6. So 6, I can use 2 and 3. 2 is prime. So I'm going to stop right there with the 2. I'm going to circle that 2. And 3 is also prime, so that stops. So check this out. We're calling this a factor tree, so think of these as like branches coming off the tree. Once you get to a prime number, you circle it, and that's the end of the branch. So let's go over to the 8. The 8 was composite, so I'm going to use 4 times 2. 2 is prime, so I'm going to circle that. That's the end of that branch. 4 is composite, so I'm going to say 4 gives me 2 times 2, and all the 2's are prime. So now when all the branches have a prime number at the end of them, that tells us we're in good shape. So are these all prime? Yeah, all the circled numbers are prime. So what we have is this. We have 1, 2, 3, 4 2's, right? 1, 2, 3, 4 2's, and a 3. Perfect. So that's the product of primes. There's product because it's multiplication, prime because we have all prime numbers. Now the only other thing I'm going to do to show that I fully understand this is I have 1, 2, 3, 4 2's. So I'm going to say 2 to the power of 4. So check out the stuff in the red and then look what our answer looks like. We have made that a little shorter, a little sweeter. We're being more efficient here. So we have 2 to the 4th times 3. And if we multiply these, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, times 3 will get us right back to that 48 that we wanted in the first place. So that is prime factorization using a factor tree like so. So what I would like you to do, you have a 40. Actually, you know what, before we go on there, one thing I didn't tell you, the 48 had a 6 and an 8. There are more factors of 48 than that. 24 times 2, 16 times 3. There are other ones that we can use, okay? So 4 times 12, so on. There's many factors. All of those factors, no matter how you don't have to use 6 and 8, no matter how you do them, will get you to here. My advice would be, however, the closer that these two factors are together, the least amount of work you'll have to do. Hint, hint. So what I would like you to do is I would like you to hit pause and do the prime factorization of 40. Go. So for 40, I used 5 and 8 because, like I told you before, those are the closest factors I could get to each other. You could do 10 times 4 and 20 times 2 and so on, but all will get you the same answer. But if I do 5 and 8, these are the closest together. It's going to be the least amount of work. 5 is a prime number, therefore I'm just going to circle it. 8 is not prime, but look over here. I already did 8. 4, 2, 2. I could actually say that 8 is 2 cubed. Right? Because I have 1, 2, 3 2's. 8 is 2 cubed. Since I already did that, I'm gonna write that down here, like so. So I have 2 times 2 times 2, check it out, 2 times 2 times 2 times a 5, like so. So 2 cubed times 5. And if you would please hit pause and do 24. So for 24, I'm using 6 and 4. You could have used 8 and 3, 12 and 2, 6 and, whatever works for you is fine by me. I'm using the ones that are closest together. These are both composite, so I'm taking 6 and I'm breaking it down to 2 and 3. We've already done that as well. 2 and 3 are prime. Taking 4, breaking it down into 2 and 2. The 2's are prime as well. So I have 2 times 2 times 2. I have 3 of those. 2 cubed times 3. So there is our factor trees showing prime factorization. These are your notes. Your homework's on the back.